In our next question, I want to take a step back, and I want to talk about why even bother with this in the first place? And we'll revisit this question many more times before we're done. But this question is titled, when do I use shell and when do I avoid shell? And I want to talk to you about what effective and ineffective patterns are when you're using shell, when you're writing shell scripts, what a hard barrier for deciding whether or not to use shell in the first place. Because for other tools, for tools like make, we have a hard barrier for if I need to do something that needs complex control flow, nope, make is a dead stop. Don't even go down that path in the first place. What's the equivalent for shell scripting? And what patterns tend to be unusually effective when you're using shell scripting? What is that sweet spot? And so let me show you an example of a shell script that I might write. And here you can see a little bit of sophistication, but a nice little shell script here. It's got some usage text. It has a dry run mode and a verbose mode. It has this perhaps inscrutable z parse ops to parse command line options. Don't you wish you had, the Python standard library's argparse here instead of whatever the heck this means? It does a little bit of processing of those args, so you can have like a -h and it prints out some help. But fundamentally, what this shell script does is absolutely nothing. An unusually effective pattern at shell scripts and an unusually apropos, unusually effective place to use shell scripts is if you're trying to automate the process of writing and running commands, then you'll find that a full programming language may actually be way overkill and maybe way clumsier than a simple shell script. Yeah, there's a little bit of verbiage at the top, a little bit of noise at the top for this, but fundamentally, this shell script doesn't do anything. It generates commands, which then themselves do something. And for this particular case, you can imagine if that dry run flag isn't set on, it'll actually evaluate those commands, but there's no need for me to even have this dry run flag. That's not even necessary. I could just have this shell script serve the purpose of emitting the commands, which I then pass to something else to then run them. Whereas make takes the graph definition and the graph execution and it conflates them. A simple, very effective pattern is to tease these apart, to just have a script that just generates commands in the form of text and prints them out to the screen, and then you decide how you want to execute them. And so I would very likely take this script and I would take any bit of this dry run, maybe even this verbose mode, and I'd eliminate that. Why do I need a verbose mode? Just assume that it's always just printing out the commands. And assume that it doesn't do anything itself. It just generates the two commands that I'm going to run. And I'll show you what this does, minus these two modes. I've made this significantly simpler, significantly less noisy, and you can see it prints out and by the way, I want this to be commands here. It prints out the commands that I want this to run. And I'm going to actually null terminate these like that. And let's just make sure that these are actually printed out as independent arguments. There we go. So now we have null terminated commands. And I'll new line terminate them so you can see, but it generated these new line terminated commands. And it generated a bunch of commands that I'd otherwise have to type. Touch A, LNS, and you can think this could be a very simple workflow. Instead of this script executing a workflow, this script could just figure out, in order to do this, I have to do this, this, and this, and just order them, print them out to the screen, and then I could take this result and I could pipe this to an executor, a Z shell, or I could custom modify this graph and say, for example, you know what? Anything that has the word B in it, I don't want. Is that a very safe thing? Who knows where that letter B could show up? But you get the idea that if I could find some string in some ad hoc fashion that I wanted to say, don't run it for this particular user, don't run it for this particular data set, I can just compose and remove that. This tends to be an incredibly effective pattern. Whenever you need to run a bunch of commands, and those commands need some sort of programmatic behavior, or you want to be able to specify something which then creates a very complex, hard-to-type sequence of flags, or you want to specify something at a high level and have a script determine what the steps are necessary to get you there, kind of like a workflow system. You could write a shell script that you can see I actually significantly reduced the complexity by eliminating this thing's ability to even execute anything. Just write a shell script that emits commands, and then you can pipe that too. By the way, you just pipe this to your shell. Pipe this out to a Z shell, and it'll actually run these, and you'll see. it'll run these and it'll create those files for you. This tends to be a very effective use case. I want to show you an example of this. And this is something which I wrote myself to automate an incredibly complicated tool that I use. I use a tool called QEMU for launching virtual machines. And the number of arguments that QEMU takes is mind-boggling. There are so many arguments for specifying so many details. And when you go and you read a blog post about QEMU, they'll give you the names of these arguments and your head will just spin. And there's so much functionality, but generally, when you think about it, when you're running QEMU, you're basically running that command over and over, which is a little bit of modification. So I decided one day, you know what? I do not want to have to store this in my history. I do not want to have to do this manually. I'm going to create my own wrapper command that allows me to do things like presets for high or low performance that automatically sets how many CPUs this gets, how much memory it takes, that automatically fills out drive or overlay or shared folder using VirtIO FSD, that automatically sets up mappings so I can expose ports, that automatically turns on or turns off, spice and the corresponding flags for spice, that allows me to, and this actually has a dry run in a verbose mode, but you don't really need that, automatically allows me to say, you know what? Using my local DNS mask, find out what the name of this host is, and then resolve that to an actual IP address, or generate a socket and launch another process. And that's probably why I have a dry run and a verbose. This thing may actually have to, do some of the execution itself. But all this thing really does is it goes through those arguments, and then it figures out what the strings are for the resulting enormously large QEMU command that I want to run, and all the steps that are needed, and admits that to the screen, and then I can write that to a shell script. I can hand edit that if I need to, or I can just run that directly. And this just tends to be something that works extraordinarily well, having a shell script that figures out the commands that you run for something else, and that saves you time. And as you begin to see what the mindset is human augmented automation. Instead of having some automation that is an entity unto itself, that is its own thing, that requires its own documentation, that requires its own, you need to be careful when you do this, you need to be careful when you do that. What I'm trying to do is I'm trying to keep everything down to the level of what would I do as a normal human being just typing stuff at my command line? How can I write a script that just speeds me up at typing those things at the command line by finding common patterns and building abstractions purpose-built to those common patterns as I go? These kind of command helpers. And I find that the more often I run a command, the more impatient I get to remember all the different flags, the more I actually want to write a command helper, not an alias or a function, but maybe a complex command helper to figure out what those arguments are and to admit that. And I find that because I'm still in this ad hoc mindset, my QEMU flags may change on a dime. I may find that, some hard-coded thing, I need to actually overwrite that. I need to do this. Well, by doing a command helper, I can always emit the output of that to a file, hand edit it, run it, and move on with my life. So as opposed to subordinating myself to the automation is really just augmenting the human's ad hoc process. This is where the shell shines. But understand, there are some cases where the shell is really a tool which you're going to have a bad time with. Remember that even though it may look like the shell has the ability to represent things like numeric values, can perform math, the shell is strictly byte stream based or string based, if you want to put it that way. You have the ability to say, this is a value that I'm going to interpret as a numeric value, but there are no integer data types, there are no float data types, there are no data types at all. There's basically strings, arrays, and associative arrays, and that's it. The shell limits you in terms of how you can represent complex or compound data types. And so, you can say, take this string and parse it as a number and do a numerical operation and store that back to a string, but you're always fundamentally dealing with strings or byte streams. You can, however, represent some slightly more complex structures, namely your shell, whether it's Z shell or bash, probably has the ability to represent actual arrays, but they're only going to be arrays of strings. And they're not going to be arrays of arrays. There's no nested or compound structures, flat arrays of strings. So, if that's all I need, then I'm good to go. Your shell, whether it's Z shell or bash, probably has the ability to represent associative arrays, what in Python we'd call dictionaries, mappings between strings and strings. That's about it. Your shell may even have the ability to do some Python-like things, like take an array of strings and another array of strings and zip them together to create an associative dictionary mapping one string to another string. That might exist. But at its core, all you have are strings, associative arrays, and arrays. You cannot do anything more complex, and the moment you need that, you're going to start having a really tough time, and you're going to find that you have grown beyond shell. Whenever I look at two different tools that seem to overlap, a Python script and a shell script, they could both accomplish the same things. I'm always looking for what is the mindset that allows me to cleave these apart. Some people call these, the thin razor, the question that slices this in two. And fundamentally, I don't think the common wisdom of, if it's more than 10 lines, write a Python script. If it's less than 10 lines, write a shell script. I think that's nonsense because my QEMU script is maybe 100, 200 lines. If I had to write that in Python, it would be a mess. It would be 500, 1,000 lines. It would be way too complicated for what it's doing. What it really is that script does not really need any data types. It doesn't need anything more than associative arrays. It's fine with associative arrays. And the moment it needs more of them, that's what's going to define if I want to move away from shell or not. With that said, there are some oddities with shell. Like, yeah, sure, it has associative arrays, but in your Z shell, it's tricky for you to determine if an associative array doesn't contain a key if there is no restriction on what a valid key is. In Python, this is nearly trivial, right? I have a dictionary, and I want to see, is a mapping in that dictionary? Is that key in there? Is A in this dictionary? Is B in this dictionary? Is C in this dictionary? Is D in this dictionary? And I just use this in syntax. And if the key happens to be an empty string itself, well, I can even do that. Is empty string as a key in this structure? Sure. If I need to do that in Z shell, it becomes kind of tricky. And here you can see, and where I want to show this to you is, if you go to Stack Overflow and you ask Stack Overflow the answer to this question, how do you tell if a key is in a Z shell array? The answer is actually wrong because it assumes that the keys themselves will be non-empty strings, but the keys could be empty strings. And you can see there's all these possibilities for this syntax. I can say, do the associative array lookup on the keys using this capital I, lowercase e with the key and quote it and don't quote it. And when you look at this table, you're just like, oh my goodness, all this detail. Why couldn't it be as simple as Python? It is the case that your use of these data types, they exist, but they're going to be a little bit more constrained because some sorts of problems are just a mess. If you look at this table, it turns out that this happens to be the right answer. This first choice is the right answer for how do you determine if a key is in a Z shell array, because you can see it's only in this first case that for whether the key actually existed or not is 0 if the key didn't exist and non-zero if the key did exist. And all the other choices, one of which happens to be the Stack Overflow answer, are actually wrong. They actually incorrectly or do not disambiguate between whether the key was there or not. And so, maybe this isn't that good, right? If I have to do some really complex, is something in a dictionary or not operations in an associative array option, maybe that's starting to stretch it a bit, and Python would be better. Definitely, if I needed to have like an array of arrays, not possible at all. Go to Python. And so, in general, your use of shell should be informed by what's really, really effective at shell, generating commands that will then be run if those commands are run just straight from top to bottom. There's no control flow between those. There's just, in order to do this thing, you do 1, 2, 3 in order, and if this fails, do that one, don't do this one, and if that failed, don't do that one. No complex control flow. But if you need custom data types, you cannot use shell. If you need to define your own data type, sorry, doesn't exist. If you need compound data types, you cannot use shell. And to really break this down for y'all, let's think about where these come up. Custom data types come up when you need to do data validation, when you need to deal with defaults, when you need to deal with polymorphic behavior, when you need to say, is this correct or not? And it's a very complex thing, like an IP address. 192.168.1.1 is a correct IP address, but 300.168.1.1 is not a correct address. I have to break it down and I have to check if each of these numbers are within 0 and 255. Do I really want to do that in shell? It'd be very easy to do in Python. In fact, the Python standard library has the IP address module. You don't even have to do it yourself. It's already been done for you. Very tricky to do in shell. Defaults, Yeah, okay, no. Can't do that in shell. You can't have a custom data type. So you can't say, oh, take this JSON data, and if some key is missing, fill it in with something. You do that very trivially with object orientation in Python. At shell, you're going to have to use a secondary tool, maybe, but you can't really represent that as a first-class entity. And any sort of polymorphic behavior. If the data happens to be of this type, perform the same named operation in a different way than if it happens to be of this type. Trivial, very common use of object orientation in Python. Can't do it in shell. For compound data types, what is your most common compound data type? A record, a tuple. You can't represent tuples in shell. You can represent associative arrays, and you can represent arrays, so maybe you can kind of get close, but usually it's not just the one tuple you're dealing with, it's a list of tuples, and since you can't have compound types, sorry. So as long as the underlying record is more or less just a string, or is close enough to just a string, shell is good enough, but the moment it goes beyond that, sorry. Complex mappings. You might think JSON is bad because you can't have keys that are anything but strings. You can't have an integer mapping to an integer like you can have in Python. Well, in shell, it's strings to strings, and you can't have a string to a mapping of string to strings. And so any sort of complex mapping, any sort of multi-level or multi-tiered mapping, not possible at all. And so here's what I want you to think. Am I over and over and over typing the same thing at my command line? And do I make little ad hoc modifications every so often? And would I like to be able to specify this more simply? One command line argument that implies other command line arguments. Shell is a great use for this, and maybe write a script that emits the commands to be run otherwise. Maybe there's some dependencies in there, maybe there's something else in there, that all fits. If you think, I need to validate some data to make this really good. Oh, I need to do some polymorphic behavior. I need to have some defaults. Go straight to the Python script or go straight to your scripting language. I need to have some sort of list of lists. I need to be able to disambiguate between, for example, commands that you might run. You might break down into the individual arguments. So you might have a list of the commands, which themselves are a tuple or a list of the arguments for that command. Go straight to Python. Don't do it in shell, because you cannot fundamentally expose or invent or express custom or compound data types. And this is my hard stop, shell or no shell, and it comes down to data types and data type representation. As long as you can get away with just strings, shell is fine. The moment you need to go beyond strings and simple associative arrays and simple arrays, shell won't take you there. So there you go.